This lesson you have been studying from grade 2 about water cycle. And then even last year, when you were in grade 6, I taught you about water cycle, nitrogen cycle, carbon dioxide cycle, I think in grade 7, term 1. So just quickly, say me the process involved in water cycle. When I say water cycle, what is the first thing that clicks your mind? What is the first thing that clicks your mind when I say about water cycle? Yes, girls? Anyone? What happens? The water from the ocean?
Evaporation.
Excellent. Evaporation. This is your first step. After evaporation, I'm sure that
Precipitation.
evaporation means it goes up. It goes up.
And then,
Okay. It goes up.
and precipitation.
And what happens?
Precipitation.
Directly it will rain.
Condensation.
Condensation. First it will condensate. And then precipitation. Then it happens precipitation. Cycle goes on. But girls, does only evaporation is involved? Or we have something else? Through plants and animals. What do we do when you take out carbon dioxide from your mouth? We respire. And plants, transpiration. So what is a water cycle? The water from the ocean evaporates. That's evaporation. It goes to the clouds. There it happens. Condensation, it cools. The water cools and condensation happens. Then it rains. That is called as precipitation. And what is the other way through plants and animals? That is transpiration. This is the brief idea. So we have to describe the water cycle and the different processes that are part of the water cycle on Earth. I think I should not take more than 1 or 2 days for this lesson again, because you have a very clear idea about it. Now, let us begin. Page number, girls, 15. Before we start the vocabulary terms, Judy, can you read the first one?
Water cycle and sublimation.
The air inside a glass of ice would feel warm or cold or to room temperature. Yes, the air inside. I think you can see the screen, right?
Yes.
Yes.
If there is ice inside, how about the air? What will be happening to the air inside the glass? Will it be warm?
Cold.
Temperature? Yes?
Cold.
Cold, because of course, when the surrounding is cold, when the ice is cold, it will let the surrounding be cold. Now, ice would melt, evaporate, or remain frozen if it is let outside on the hot day. Melt, evaporate, or remain frozen. Zishan.
Yes, miss.
Would melt, evaporate, or remain frozen. Choose one.
I would melt ice with
If it is left
evaporate.
outside, if you leave
It will
ice,
melt.
first it will melt. First thing it will melt. Later on it will evaporate. But first thing it will melt. Water vapor will condense or evaporate from melt into the glass of ice from the air. Water vapor will condense on a moment, guys. Yes. Water vapor will condense on the glass of ice or evaporate from, or will it melt? When you see the droplets of water on the glass of ice from the air, It will condense, girls. It will condense. The ice absorbs energy from the ice. Does it absorb energy or maintain energy or release energy? When it melts, it releases energy, girls. These were the three things. Now the vocabulary terms. Please, can you read the vocabulary terms, Zishan?
Water cycle, sublimation, evaporation, condensation, transpiration, precipitation.
Okay, so water cycle, evaporation, transpiration, sublimation, condensation, precipitation. Do you know the meaning of everything here? Is there any term you don't know at all?
Sublimation.
Sublimation, okay. I wish I would have been in the school to show you this, because anytime I have taught sublimation to my students, I always show them this experiment. And even today, I can just show you on the YouTube, okay? Like exactly, you will never forget sublimation after this. Give me a moment, 1 minute, girls.
It grows with Amazon. Join today with a small investment of $250.
Now, girls, here I'm just showing you a small experiment which explains you sublimation. The word sublimation means directly from solid it will become gas, or from gas it will directly become solid. It will not become liquid at all. From solid it will not melt. It will directly become. Now see how it shows. If we were at school, these are iodine. They are always shiny gray color. These are iodine crystals, girls. These are iodine crystals. We put iodine, we heat them. According to you, when you heat something, that becomes liquid, right? That becomes melting, that melts. But here it is opposite. They will directly form fumes. Are you seeing here?
Yes.
Very beautiful purple color, girls. Imagine, subhanallah, the color of the crystals is silver gray, and when you heat it, you get purple, and when you put water, it is brown. Now see, what did they do? Now they want to show you, this was solid to gas. Now the gas, how will it become solid? They will show you. They put ice here, that means it cools. Here it was heating, and now it is cooling. So while cooling the ice, see how it changed to directly solid. Normally, when you cool water, gas, it turns to vapors and then to water, liquid. But here, directly from gas to solid. The gas coming out will go and stick. After some times, you can see a layer there. See? All the iodine crystals, they went and they stuck onto the. Did you see this? These all are iodine crystals. Similarly, when you open your refrigerator, the solid ice directly turns to solid ice. Sublimation. See, this is called a dry ice.
This is dry ice, which is the solid form of carbon dioxide. Carbon dioxide does not have a liquid state under normal atmospheric conditions.
Can you see?
So it turns
It is
directly
not
from a
melting.
solid into a gas.
Directly it is?
As it turns into a gas, it creates
Directly
a
to
little
gas.
layer
Can you
of
see that,
gas
girls? This
underneath
is not the ice
dry
what you
ice.
are having the ice in the fridge.
And so the dry ice can slide around kind of like a hockey puck on top of a layer of air.
You get it, girls?
You may have noticed that there is some liquid on the table. That liquid is water. It results from the fact that water from the atmosphere in the form of water vapor has deposited on the very, very cold dry ice. If you look very closely at the dry ice, you can see some fuzzy crystals of water vapor
Can you see that,
are now
girls?
frozen in solid form.
Any question?
If I
So this is sublimation. This is called as sublimation. So movement of water between the atmosphere, land, oceans, and even living things, these all make up the water cycle. When I say precipitation, that doesn't mean only rain water comes out. It could be snow, hailfall, and this all they come down because of gravity. If there was no gravity, they couldn't land up. They couldn't land down. On land, ice and water flow downhill. Water flows in streams, rivers, waterfalls, as one in the photo, because of gravity. If the land is flat, water will collect in certain area, forming ponds, lakes, and marshland. But if it is not flat, it will go and run into ocean. Even groundwater flows downhill. Water and snow can move upward if they turn into water vapor and rises into the air. Plants and animals also release water vapor into air. In the air, water vapor can travel great distances with the wind, which can also move the water in the surface layer of the ocean by creating ocean currents. You have studied about ocean currents there. Now here, girls. When you see this picture, under each photo, write an example where you might find water in that state matter. Like girls, these are oceans. These are maybe Antarctica and Arctic oceans. And this is where the water vapors, like Garden. Water is found in 3 states. Now, water evaporates. First, solid melts to form liquid. Liquid evaporates to form gas. Gas, again, they turn into rain, and then it deposits and again form ice. Now, water is found. Please, can you read it? No?
Water is found in 3 states on the earth: as liquid water, as solid water ice, and as gaseous water vapor. Water is visible as a liquid or a solid, but it is invisible as a gas in the air. Water can change from one state to another as energy is absorbed or released. Water absorbs energy from its surroundings as it melts from solid to liquid.
This is what you are learning, new girls, that water absorbs energy from its surroundings as it melts. So when it is melting, it absorbs the energy from the surrounding to from solid to liquid. It also absorbs energy when it evaporates. Like solid to liquid, liquid to gas, it is absorbing energy. And when it is back, gas to solid or gas to liquid, it is releasing energy. So what we have to remember, this one, when it is melting from solid to liquid, energy is absorbed. Do you see this arrow, girls? When it is solid to liquid, it is absorbed. When it is liquid to solid, the energy is released. Will you remember these, girls? This is important.
Yes.
That when it is solid to liquid, the energy is absorbed by water. When it is liquid to solid, energy is released by water. So this is what higher grade we have studied, something new. Water also absorbs energy when it evaporates from liquid to gas, or when it sublimates from solid to gas, also it absorbs. Water releases energy when it is coming back. See, simple, girls, there are 2 arrows, 3 arrows like this. Solid to liquid and liquid to gas. Okay, I'll just write here, solid to liquid. So during this state, It is melting and evaporation. It is absorbing energy. What do we call? Absorbing energy from water. Absorbing energy from water. Now,
Water.
it comes back. Gas to liquid, condensation. Liquid to solid, freezing. This time, it releases energy. It releases energy from water. So did you get it? Is this point very clear?
Yes.
When it is absorbing and when it is releasing, girls? A moment, girls. Okay, girls, here. Water also absorbs energy when it evaporates from liquid to gas. So I told you there are two things, when it is absorbing energy and when it is releasing energy. Now let me ask you questions. Okay, Zishan, if I ask you from solid to liquid, is it absorbing energy or is it releasing energy? From solid to liquid. Zishan, from solid to liquid, is it absorbing energy or is it releasing energy?
Releasing.
Solid to liquid, what is the direction? Solid to liquid, the direction is this way. This way it is absorbing and this way it is releasing. Solid to liquid. This is liquid to solid, coming back. Solid to liquid, remember it is absorbing.
Okay.
And when it is coming back, it is releasing. Now you tell me, from liquid to solid. Tell me, liquid to solid. Releasing or absorbing?
Absorbing.
Again, wrong, Judy. Judy,
Releasing.
this is solid. This is liquid. I'm saying liquid to solid. Look at the direction. Liquid to solid means coming back. When I said coming back, that is, when I say coming back, what is it? Liquid to solid, girls. Liquid to solid, it is releasing. Solid to liquid, it is absorbing. Look at the directions. Again, liquid to gas. Liquid to gas.
Absorb.
Gas absorbing energy. And when we come back, gas to liquid, it is releasing.
Releasing.
So while going, it is absorbing. While coming back, it is releasing. This is the main part which you have to know in grade 7. Because water vapor, the water cycle, you all know. But this is the part for you. That's the reason I stopped here. Until and unless you don't understand this part, it's better I don't go to the another part of the lesson. So if you still don't get it, please ask me.
If it's from solid to liquid, it's releasing.
Yeah, like example, if I ask, what happens during evaporation? What is evaporation? First question. Evaporation is liquid to gas. So liquid to gas, what will happen? Will it absorb energy or release energy? From liquid to gas. Look at the arrows. Look at the arrows and tell me, from liquid to gas, what will happen?
Absorbing.
Excellent. If I ask you what happens during freezing? Freezing. What is freezing?
Releasing.
Yes, freezing.
Release.
Freezing is liquid to solid. So that time it is releasing. Noor, did you get it or no?
Yes.
So we have evaporation. About 90% of the water comes from evaporation. We have transpiration. That is release of water vapor into the air by plants is called transpiration. Liquid water turns into water vapor inside the plant and moves into the atmosphere through stomata. Stomata is the organ. They are tiny holes on the plant surfaces, and this is called as transpiration. And finally, we have sublimation. I have shown you the iodine and the dry crystals, how directly it will change from solid to gas. Whenever sublimation word comes in your life, you'll remember it is direct from solid to gas or from gas to solids. So we will directly see the video for a few minutes and continue tomorrow.
Welcome to the lesson, The Water Cycle. In this lesson, you'll learn about how water cycles through the Earth system as it changes state, is affected by gravity, and absorbs and releases
Now,
We can't see
Yes.
the video. Now, yes.
now yes? Okay.
energy.
Yes.
The vocabulary words for this lesson are water cycle, evaporation, transpiration, condensation, precipitation, and sublimation. Click each word to learn more about it. The water cycle does not use up water. Water that dinosaurs drank 100 million years ago is still somewhere in Earth's water cycle today.
Wait a minute, Coach.
Water can be found in 3 states on Earth, as a solid, a liquid, or a gas. Anytime water changes state, energy is transferred either to or from the water. Click each picture to learn more about how water changes state. When water freezes, it changes from a liquid to a solid. As water freezes, it releases energy to its surroundings. Melting is the process of changing from a solid to a liquid. When water melts, it is absorbing energy from the surroundings. Sometimes this energy comes from the sun. You can remember this if you remember that liquid water is almost always warmer than ice. Evaporation is the process of a liquid changing into a gas. When water evaporates into water vapor, it absorbs energy from its surroundings. Sometimes this energy comes from the sun. Condensation is the change of state from a gas to a liquid. When water vapor condenses into liquid water, energy is released to the surroundings. Sublimation happens when a solid changes directly into a gas without first becoming liquid. When water sublimes, it is absorbing energy from its surroundings.